Today we're going to look at how to multiply polynomials. So as a reminder, when you are multiplying polynomials together, you always add the exponents. So since we are in a unit about quadratics, we are going to only see x times x, which is equal to x squared. I also want to add in a reminder that when you are adding variables together, you do not add the exponents. So if I was adding 3x plus 2x, then that would simply be 5x, and I would keep the variable in x. Same thing if I was adding 3x squared plus 2x squared, then that would be 5x squared. So when you're doing addition and subtraction, your variable and your exponent is not going to change, only with multiplication. So when you're multiplying two monomials together, just like example 1, that would be two monomials, you're multiplying the coefficients together and then you're multiplying the variables together. So for example 1, I would multiply 5 times 2, which would give me 10, and then x times x is x squared. For example 2, the coefficient of negative x would be a negative 1. So I'm multiplying negative 1 times 4, which would be negative 4. And then again, x times x, which is x squared. For examples 3 and 4, we're multiplying a monomial times a polynomial. So when you're multiplying a monomial outside of parentheses to a polynomial inside of the parentheses, you are doing distribution. So we are going to distribute, on example 1, the 5x to everything that is inside of the parentheses. Okay? When I do that, I'm doing the exact same steps now that I did in the first two examples. You're multiplying the coefficients together, and then you are multiplying the variables together. And as a reminder, when you multiply x times x, you will get x squared. So I would multiply 5 times 3, which is 15, and x times x, which is x squared. So I got that by multiplying 5x times 3x. Okay? Then we are going to multiply the 5x times a negative 4. Remember, when we have subtraction, that means that that number is negative. So 5 times negative 4 is negative 20. And then I'm multiplying x by a number that doesn't have a variable, so it would just stay an x, and this would be my answer. You are allowed to multiply things that are not like terms. So for example, 5x and negative 4, we are allowed to multiply those together. You just only multiply the numbers together and then the variables. So for example 4, we would distribute the negative 4 to everything inside the parentheses. So I would multiply negative 4 times 2x squared. Negative 4 times 2 is negative 8. And then again, I have an x squared, but I'm not multiplying the x squared by another variable, so it would just stay x squared. Then negative 4 times negative 3x. A negative times a negative would make a positive. 4 times 3 is 12. Keep the x, and then negative 4 times 5 is negative 20. For the remaining examples, we're going to be multiplying two binomials together, okay? So I'll talk about the steps that it lists up here, but this is most commonly called the FOIL method, and that's what this step right here is saying. This is called the FOIL method, standing for first, outside, inside, and last. If I were to give you example 5 blindly and ask you to multiply those, most people would multiply the 4x times the 3x, because those are like terms, and then multiply the negative 2 times the 5. But when you're doing multiplication with parentheses, you need to make sure that you are distributing. So to simplify this problem, I am going to distribute everything that's in the first binomial to both of the terms in the second binomial. And this will create 4 terms. So the FOIL method is going to help us remember first, outside, inside, last, that I need to multiply 4 different things together when I do this problem. Okay, so first I am going to multiply the 4x times the 3x. So 4 times 3 is 12, and x times x is x squared. Then I'm not going to jump to the -2. We then need to multiply the 4 times the 5. So 4x times 5, 4 times 5 is 20. And the x is going to stay an x since it's not being multiplied by another variable. Then I multiply the -2 by both the 3x and the 5. So -2 times 3x would give me -6x. And then -2 times 5 would give me -10. Now we need to be careful, particularly with this last one. For some reason, students always multiply, and then they see -2 and +5, and they write down 3. They just go ahead and add them in their head. So make sure that you follow through with multiplication for all of the steps of FOILing. Okay, so the next step is to combine like terms, which is the OI. So you are most of the time going to be able to combine your middle 2 terms, especially if you follow the method of FOIL and you multiply in that order. 20 and -6 are like terms because they both have the variable x. 12x squared is not a like term because of the x squared. Now, when I combine these together, I'm only going to combine the coefficients. So 20 minus 6, which would give me a +14. And then we keep the x, okay? It does not become x squared. The x doesn't cancel out. It's going to just stay 14x and then -10. And this would be my final answer. So for example 6, we're going to approach it the exact same way with the FOIL method. So I would start by multiplying 2 times 8. So 2m times 8m would give me 16 and then m squared. Then the outside terms would be 2m times -1, so -2m. Inside term would be 7 times 8, so 56m. 7 times 8m. And then last, I'm multiplying +7 times -1, so -7. Then we combine like terms, which in this case is my middle 2 terms again. -2 plus 56 is a +54. So my final answer would be 16m squared plus 54m -7. In example 7, I have a binomial that is squared. So common instinct to have right away is to distribute the exponent, but we never distribute an exponent. We only distribute a coefficient if there's a number that's in front. What an exponent means, if this expression is being squared, that means it's being multiplied by itself. So when I see 2m plus 7 squared, what that means is I am multiplying 2m plus 7 times 2m plus 7. So anytime you see that something is squared, that means that you should write it twice, and then you would FOIL. So now we're going to use the same process we used on the last 2 examples. I would multiply 2m times 2m, which is 4m squared, then 2m times +7, which is a +14m, 7 times 2m, which is again a +14m, and then 7 times 7, which, be careful, is not 14. You're multiplying, so that would be 49. Then combine your middle two terms. 14 plus 14 is 28m. So this would be 28m plus 49. For our last example, we have a number that is in front of the parentheses. If you have a number that is in front of the parentheses, it is okay to distribute it at the beginning, but if you distribute it, you would only be distributing it to one set of parentheses, which people always mess up, and they tend to distribute it to everything. So my advice and the way that I'm going to show it in this video is to wait and apply that number and multiply it and distribute it at the very end of the problem. So I would start with just foiling the 5x minus 1 times the 5x plus 1. So multiplying 5x times 5x would give me 25x squared. 5x times positive 1 is positive 5x. Negative 1 times 5x is negative 5x. And then negative 1 times positive 1 is negative 1. Okay? Combine your like terms. Be careful on this one. 5 minus 5 is going to give me 0. If I write an x down on the paper, then I would be saying that it's 1, because that would imply that there's a 1 in front of the x. So we're not going to write 0x. If these terms cancel out, then they cancel out, and I would just be left with 25x squared minus 1. Now, we need to be careful, and we can't forget that the number is in front of the parentheses. So we had a 4 here. We need to make sure that we bring that down and that that is still in the problem. And now I would distribute the 4 to all of the terms inside of the parentheses. So 4 times 25 is 100. I'm not multiplying the x squared by another variable, so it will stay x squared. And then 4 times negative 1 is minus 4. And that would be my final answer.